It's important to note that all of the examples we've provided so far are very simple. They only have one or two dimensional inputs. In this example here, we have two inputs. We have x1, the hours of exercise per day, and x2, the calories consumed per day. That's a two-dimensional input vector because there's two inputs. But you could imagine that in many real-world machine learning tasks, you have way more than two inputs. You could imagine if there were three inputs, so we had an x3. Now all of a sudden we have a three-dimensional plot with a z-axis that's coming out of the screen. So in 3 dimensions, let's think about what we need to do to separate points there. So just imagine that you have a bunch of circles and squares out in 3D space, and you want to find a shape that can best separate them. We call this shape, when it's linear, a hyperplane, which is a generalization of a line in multiple dimensions. So you can imagine that, the sheet of paper is not important, but you can imagine you have a bunch of points out in 3D space, and you have a sheet of paper that separates the points, and it could be in all sorts of angles and orientations and directions. So if you're doing machine learning where you have 3 inputs and you're trying to classify them, and you're using a linear technique, then you're limited to a hyperplane in that 3-dimensional space, which separates the points. If you use more complex classification techniques, then it doesn't have to stick as a plane, but it can be all curvy and like this, and conformed, and separate points in more complex ways than just some straight linear boundary. And beyond 3 dimensions, so in 3 dimensions it's a plane, beyond 3 dimensions it's a hyperplane, which is hard to visualize as humans, but it's the same concept. Just imagine a plot with 4 axes, or 10 axes, or 1,000 axes, which happens all the time in real-world machine learning. You can imagine there's 1,000 inputs to your machine learning model that's trying to predict between 2 things or 5 things. And so you would have a large plane, hyperplane, in that 1,000-dimensional space. In other words, that plot with 1,000 axes. We find the shape that can separate the points in that space with 1,000 axes. So worth pointing out that all the concepts we're covering in this series can be generalized to higher dimensions. And it's basically the same idea, same math, same concepts, just in these higher dimensional spaces. Don't let this notion of higher dimensionality confuse you or scare you off. It's the exact same thing as what we see in this picture. Just add more axes.